Rahman, and this is my RWA number 2. Today I'm going to be describing the projectile motion equations with a simple skateboarding trick. In a hippie jump, the skateboarder rides along a flat horizontal surface with a certain velocity, then jumps straight up without exerting any horizontal force on the board. This allows him to fly straight up in the air at the same horizontal velocity as the board. The board remains directly below him and he is able to land on top of it. The skater must propel himself up by pushing vertically down with his legs. If he pushes on the board with even the slightest horizontal force, the board will shoot out either in front of him or behind him. After the skater jumps off the board, gravity takes over and he follows a parabolic arc as he flies through the air, before landing back on the board. According to the equations of projectile motion, only the vertical component of a velocity changes, since gravity only acts on the vertical component, or the y direction. The horizontal component of velocity, vh, of the skateboarder stays the same since there is no force acting on him in the horizontal direction, neglecting air resistance. The force acting on the board as it rolls along due to the contact with the ground is small and doesn't slow the board down appreciably. As a result, its velocity is approximately the same as the horizontal velocity of the skateboarder. This allows the skateboarder to land back on the board. This figure shows the motion of the skater under the influence of gravity only. We are assuming no air resistance, so the skater travels exactly as he would while in a vacuum. Delta dx is the change in the horizontal position. Vx is the horizontal velocity, which is constant. T is time. Delta dy is the change in vertical position. V1y is the initial vertical velocity. G is acceleration due to gravity, which on Earth is 9.8 meters per second squared. V2y is the final vertical velocity. V1 is the initial launch velocity. Theta is the initial launch angle. Thus, we have the following equations describing the motion of the skater, projectile in the absence of air resistance. Note that the horizontal velocity Vx is treated here as a constant because it is assumed that there is no force acting on the skater in the horizontal direction, since air resistance is neglected. Therefore, only the vertical velocity of the skater changes since there is only a vertical or gravitational force acting on him. Note that the equations are a direct result of applying the equations of rectilinear motion using constant vertical acceleration in the downward direction, g, and zero acceleration in the horizontal direction, since there is no force acting on the skater in the horizontal direction, since air resistance is neglected.
Said no more counting dollars, we'll be counting stars. Yeah, we'll be counting stars.